Hi guys, let's dive in. This is a recap session and we're going to look at, in simple terms, some of the data types, specifically focusing on strings, but we will look at some of the numerical ones. And we'll undertake some simple input and output. And in order to do that, we're going to develop a silly program called the Useless Trivia Program. So let's get cracking. Let's open up the folder that I've been working in and bring up our Python files. So to do that, let's open folder, go to my workspaces one, and these are the variable strings and input output Python files. I'll OK that, and they've opened up that side. Okay, so this is my first file I want to look at, test.py. And here we've got the familiar string, hello world. Open a terminal, so packages, and then find your terminal one and click toggle to open that. Right, okay, so again, this is print hello world. Let's just run it, Python 3.6, and I've got it stored under test.py. Okay, and there we go, it's run hello world. Now, there's one thing different about this one, and this is that line across the top here. Okay. This is called the hashbang, and the hashbang is, or the shebang, sorry, is the name of the two distinctive characters, yeah, where we've got the hash symbol, the octothorpe or the number sign, followed by an exclamation mark at the beginning of the script. Yeah? So there are a number of ways of using that. So it's used predominantly in Unix-like operating systems such as Linux, specifically with text files, when it's to be used as an executable. Yeah, so that means we're going to execute the program, yeah, and this puts at the top of the file the program loader, so in this case the Python interpreter, which is going to execute the commands within the file. So it's a nice, fairly simple way of being able to execute your program files without putting the Python 3.6 bit at the front. In order to do that though, we need to quickly change the permissions. So if we look at the permissions of our test.py file, okay, by using that ls-l command, and our permissions are there, okay, in those 9 blocks of letters. So we've got RW for read write and a blank space there, which could have an X for execute, and then we've got another block of 3 and then another block of 3. So the first block of 3 is for the owner, which is me, the owner of the file. That is for the group, which I'm in a group of users, and and this block is for any other users of the system. So to add the execute bit to there, I just need to work out what number this is. Each one of these values, each one of these little bits here in this block of 3 has a value. That's 4, that's 2, and that's 1. So at the moment, these permissions are 4 and 2, which is 6, 4 and 2, which is 6, and then 4. So we could read that as 664, or read write, and read. To change it to the execute, I just need to add one more bit here, so then that will become 4, 2, and then 1, which gives us 7, and then we can leave the other permissions as there are. 764, add that to my test.py file, and then if we look at the permissions again, we can now see that it's got execute permissions, and I can run that file now just by typing test.py. And there we go, it's run. Now the reason that happens, as I say, is because we've got this hashbang or the shebang at the top of our Python files. So I'm going to do that quite a bit through. Don't worry about understanding the Linux permissions, you'll come across those, but if you put the shebang at the top and then follow that chmod 764 and then the file name, you'll be able to do the same thing with yours. Okay, so that's how we can open and quickly execute our Python files. So let's just pop that up there, clear that off, and let's let's have a look at our file that we're going to develop today. So we've got a file called trivia.py. Okay, so if I just run that chmod command on the trivia.py and then run it. Okay, this program introduces a number of aspects that we're going to be covering. So for example, it's going to cover some maths inside our program, how to get input from the user. We're going to be looking at different kinds of string formatting, and then we're going to look at how we print all of that out, as well as pause the program at the end. So this program takes 3 pieces of information from users: their name, their age and their weight. And from these relatively mundane items, we're going to produce some amusing yet trivial facts about the person. So for example, how much you might weigh on the moon. Now it is a relatively simple program, but if you add user input into a program, users tend to care more about the results because they feel tailored to you as an individual. And this holds true for kind of all kinds of programs, from games to business applications. So let's just run through the program once and have a look at the output. So what is your name? Age 45, weight in pounds approximately. Okay, and there we are. There's some output. Yeah, some of it's silly, some of it's relatively interesting. So before we go into actually looking at creating that program, let's go through some of the aspects that we used to be able to create that. Okay, so let's drop down there. Now, one of the things that we did was print some strings out, which is pretty much standard of what we've been doing over the last couple of weeks anyway. But this is a example of a simple string. Yeah, so we're using the print function, we're placing the string inside of our quotes, and then we're going to print that out to screen. Okay, so it's really easy to represent text in our programs. Yeah, but we have to create our simple strings by surrounding this text with quotes. Now we can either use a pair of single quotes, yeah, or we can use a pair of double quotes to bookend our strings. So for example, if I was to change this one to single strings, that's still valid Python. Okay, and I can save that and I can run it in a moment. So that string will print out exactly the same as that one. It'll add a new line character at the end of here by default, yeah, and it will just print those lines out. So if you'd like to think of these as little bookends, telling the Python interpreter where the strings start and begin. Okay, now there is another thing that we can do. Okay, and that is we can use triple strings. Okay, our triple quotes to bookend our code. And what that does and how handy that is it allows us to manipulate the program and allow us to type the string in directly, the string literal, directly as we want it to appear on our screen, without worrying about the print statement having to be repeated line by line by line, as you might have done when you originally solved this one. Okay, so those are the triple strings. So again, it doesn't matter which ones you use. You can use triple single quotes, or you can use triple double quotes. Yeah, they will print out exactly the same as you type them. So if we run this program now, run it. Okay, we can see that's printed out. Now, another thing that you might have noticed here is this line at the bottom. Now, as I've said before, under normal circumstances, the print command, the print function, by default adds a new line character at the end of that. So this means that any subsequent calls to the print would display on the following line, as we've seen up there. Now, under normal circumstances, this is what we want to do, but if we wanted to add our own string at the end of the line, we could, for example, say that our line ends with spaces, or in this case I've used dollars, but we could make more sense by using ellipses. Yeah, save that and run it again. There we go. So we've done that by adding some data into the print function in the form of this parameter. So in this context, this code prints the text "here is ... a neat little trick" all on one line. That's because the first print statement, yeah, I've specified that the ellipses be the final string to be printed, so it prints that on all one line with no new line character added. So the next print statement, a neat little trick, right after the ellipses, follows on straight away. So this is that parameter, and you can put any kind of string in there if you want. I could just add a simple space. I'll do it again. It'll just carry on all on one line without the user being aware that there's other information in there. Now, don't worry about parameters too much. We'll come across and we'll deal with those when we start looking at functions in a couple of weeks. But needless to say, they are useful, and you can get more information from the help documents about the print function if you want to know more on that. So, quick recap there. That's covered single quoted strings, double quoted strings, triple quoted multi-line strings, and how to manipulate how the print statement ends and you can define which string that you want to end it with, as opposed to the default new line. Now, there are some other things that we can do in terms of our programs, and that we can use what we call escape characters or escape sequences. So let's open this one. This is called fancycredits.py. So, and if I just change the permissions on that, we can run it. A bit bigger. Right, okay, and there we are. We can see it's running. So fancy credits by me, and then some special thanks goes out to the people who supported me in the making of this movie. Right, so what we've done here, as you can see, that this is indented somewhat from the center, and the way that we've done that is by using these specialist characters inside of our file. Now, at the moment, it looks a little bit kind of cryptic in a way, but these actually make sense when you understand what these mean. So, if you wanted to indent text in a word processor, yeah, at the end of a paragraph, say, or something like that, you'd press the tab key. Well, the escape sequence \t, yeah, mimics the use of the tab inside the string. So to move that string fancy credits along, I've entered in 3 tab stops. Now, if I wanted to print a \, yeah, so we've got to be careful how we use that, because the computer itself can interpret a \, as the beginning of a escape sequence. Well, in order to be able to get around that, we just put 2 backslashes in a row, as we can see here, right, which gives us the 3 tabs followed by the 7 backslashes, which get printed out there. Now, again, we've talked about the new line character being added by default at the end of a print statement. yeah, unless we use our end parameter. However, we have got a new line escape character which is represented by the \n. This is one of the most useful sequences at our disposal to be able to format our text in a way that we like, and we can use the new line characters, the new line escape sequence, right at the beginning of a string to separate it from the last text printed. We could add it in the middle of a string, but bear in mind that wherever we add it, it would add a carriage return and return the quote and return the string back to the end, to the start of the line. We can also insert quotes into our text, which is fairly easy. We can use the \, single quote to put in single quotes, and the \, double quote to put in double quotes. They simply mean put a quote here and won't be mistaken by the Python interpreter as a marker for the end of the strings using the double, single or triple quoted bookends that we've talked about. Okay, and as we can see there, that prints out the great without the backslashes. And likewise, just have a look at what I've done to quote what my hairstylist Lou says as a general rule of thumb. Okay, we've got another escape character, \a, which would sound the system bell, so your terminal might beep when you run this, but that depends on the configuration of the terminal, the platform that you're using, and to some degree the operating system, but it's a useful alert to add to users. Okay, so these are the escape sequences that you'll use, and generally speaking they'll only come into effect when you run the program. They should not impact in any way when you're doing the code. I've put another little program there called escapesequences.py, which shows you the escape sequences that you need as a little terminal help file, but also a basic description. But inside the code, okay, you can see how they're used. So to some degree you can copy and paste them out. So for example, that will give you the single quote, that will give you the double quote, that will give you the bell sound, etc. But notice that I've had to kind of almost escape out my backslashes before the strings so that I was able to print these out. Okay, so those are escape sequences. Now, there's one thing that we haven't touched on yet, and that is how we can join strings together. Now, as we've talked about already, we have got an addition operator as part of our program, but we also may need to join two strings. Okay, now we can do that by using the concatenate operator. Yeah, now this is a special character used in the context of strings, but it is the same as the addition. Yeah, and to some degree you can think about it as the same way. You are joining two strings together so that their exact values become fused with no space or separator character inserted between them. So if you were to join up two strings together, such as cup and cake, you'd actually end up with cupcake and not cup space cake. And we can see that by looking at how we concatenate these strings here. Okay, so if I just run that file and change the permissions on it first. Okay, we look at the first line there. You can concatenate two strings with the concatenate operator, plus. If I remove that space there, which I've manually added in, save the file and then rerun it, yeah, we can see now that that space has disappeared. Okay, so if you are going to concatenate, either add the space there or add the space at the start of the next word. And it doesn't matter because there's the space put back in. Okay, now this one, you can show that you can concatenate until your heart's content, really. It doesn't matter how you do it. I mean, this doesn't make sense, and it's a little bit ridiculous, but it does give you an example of how much you can concatenate. I'd also like to point out that because we're breaking up the string with speech marks and concatenate, one print statement is able to print this out. But it does read as one long string, which is printed out, apart from when we've added the new line escape character there to print on a new line. Okay, this bit is worth noting, and again it's the indentation here. Because we're on separate strings, we need to make sure that our crazy silly string is readable, and in order to do so we put the indentation in. If you don't get the indentation correct, if I backspace out, you're going to get an error. So continuation line under indented. So just watch out for that, and then just add the appropriate amount of spaces in to fix that. Okay, we've also got a way of multiplying strings, and we can do that literally using the multiplier element there. I've called the string function and a method called upper, to turn that string from lowercase into uppercase, which as we can see that's there, and it's repeated pi 10 times. And then I've just inserted 2 new line characters to end the file there. Okay, so that's a quick recap. This is how we can concatenate or join strings together using the overloaded addition symbol, which when used in the context of strings, joins them or fuses them together. Okay, so let's move on now and have a look at our wordproblems.py file, so we can have a look at working with numbers in terms of strings and providing some output. So let's just make this one executable, and then let's run it. Okay, so we've got some simple strings, and we've asked an input to put that in there, and we've got these word problems, which you might have seen in terms of mathematical things and stuff like that. Okay, so the Python file is going to solve the problems for us, which is absolutely fine, but we've got 2 different types of numbers available to us in this. Okay, we've got floating point numbers, or floats, which are numbers with decimal places, and then we've got integers, which are whole numbers, so numbers with no fractional part. We've also talked about and used our mathematical operators before, which if we just quit that program, we can have a look at those. Have a look at those here just to refresh ourselves. Okay, so we've got our addition, which we've talked about before. So an example would be 7 plus 3. We've got our subtraction, multiplication, our true division. Okay, we've got our integer division, which gives us how many times a whole number would go into it, and then we've got our modulus, which gives us our remainder value. So those are the operators, and we can use those operators in our program, and we've done so here inside this word problems one. Now we've linked those together to allow us to undertake some maths inside here. So we'll just run our word problems one again. Right. So, if a 2,000 kilogram pregnant hippo gives birth to a 100 kilogram calf but eats 50.5 kilograms of food, how much does she weigh? Okay, this is relatively simple, and we can put the output there. And so 2,000 minus 100 plus the 50, it should be 50.5. I'll change that. Yeah, which gives us an output. This line here is the string, yeah, and then we're separating that off, and we're using integers here, and that will return the evaluation of that particular sum. So 2,000 minus 100 plus 50.5. Okay, that's returned and just printed out that value. It's not printed out the equation. It's just printed out the value. So, if we look again at the next one, if an adventurer returns from a successful quest and buys each of his 6 companions 3 beers, yeah, how many beers are purchased? Click to find out. Relatively simple multiplication, which again, we've used the integers here, and that pulls that out. Oh, we've also got our next question, which is 4 pirates find a chest full of 107 gold coins and they divide it up evenly. How many whole coins does each of them get? Okay, so this is returning excuse me, our integer division. Yeah. So if we take the 107, each of them would get 26 whole coins. But how many coins are left over? Well, we can use our remainder or our modulo division to find that out. And again, in all these cases, we've used the integer as part of a string to be able to print that out using the various mathematical operators. Okay, so far, so good. The next thing we need to think about is looking and recapping ourselves on variables. Right, now at the moment, the strings and the programs that we've been using haven't really done much with variables at all. So let's have a look at our Greeter program. Let's just change the permissions on that. Alright, so a variable provides a way to label and access information, yeah, instead of having to know exactly where it is in computer memory. And as we've said, the variable in essence creates a kind of memory box upon which you can put a label and call it something, and it can put some data of a specific type inside that box. If you like, it's kind of speed dial in essence, that you can call your friend by storing their number on a speed dial in your phone, and you can call them regardless of where they are and it will connect through to them. So, simple variable. Now we create a variable called name. Okay, here we're using the assignment statement instead of equals. So this is a single equals is assignment. If we wanted to do actual equals to say something equates to something, we'd use double equals. But we're not doing that at the moment. Okay, and in here I've stored the string rehab. So technically, an assignment statement stores the value on the right side of the equals side into the computer memory of the box that we've stuck a label on, which is the name on the left hand side. Okay, so what we're saying here is that the variable gets the value, yeah, or we can say that the variable is assigned the value. So that gives us some way of using them. Now we can use our variables just by simply calling them into where we want them. So like I did with the integers in the last one, we've put our string in place and then a comma, and then we can put our variable in there. And as we can see, so we're storing the name Rehan, so it's printed the variable there and give us the name, and then we've used that in a string as a separate parameter and called it that. Okay, so we've talked about naming values, naming variables, so it's worthwhile going back and refreshing your head on those. But one thing is important, is this concept of self-documenting code. Now, self-documenting code is code that is written in such a way that it's easy to understand what's happening in the program regardless of any comments. That doesn't mean to say you shouldn't write comments, because comments are unbelievably important, but nonetheless, choosing good variable names and laying out your code in an appropriate manner is an easy way to do that. Okay, so let's take our greeter program and let's take it one step further by getting some user input. Let's just change the permissions of that. A minute. Okay, so what we're doing here is we're taking some input from the user, and this isn't overly difficult because we've got the input function here. Now, the left side of the statement that we've got there, so name equals input, is exactly the same as in the previous one, where we've created a variable, and we're going to assign a value to it as we did before, because we've got the assignment statement there. But what we're doing in this case is we're using the input function to get some text from the user in the form of a string, which is really quite important. We'll come back onto that. And assign that and put that in the name variable. So the input statement prints something out onto screen, as allows you to prompt the user to undertake some kind of input. But then the input function waits for the user to enter something, and only when the enter key is pressed does the input function return back whatever the user has typed in, and it returns that as a string. Okay, so that's worthwhile remembering. So the string, or the return value of the function call, is what is stored in the name variable. So to help visualize how this works, imagine that the assignment statement and the call to input is replaced with the string that the user just typed. Now the code doesn't actually do that, then naturally it just returns the values directly. So if you're still not 100% clear on function calls and arguments and return values, don't worry, we're going to come back onto those more at a later date. But for now, let's just consider how our personal greeter program works. So it makes no difference how the computer gets the name value. So we can either assign it by putting in a pure string, or we can use our input statement to allow the user to get the string. So either way, that's fine. So here is our input statement that we've executed. One parameter is telling us to print out the prompt. So I'm going to put my name in. It's going to capture that string Bren there, assign it to the name variable, and then it's going to print out hi and then the content of the name variable, which is Brent. Right, and there we go. So that's how we can use various different ways of quoting strings, adding strings together to join them with the concatenator, and we can also undertake some mathematical in our program and let the output be returned directly to the user. Now let's have a look at some string methods. Now, as I've mentioned before, everything in Python is an object, and Python has a really rich set of tools for working with string objects. So these data types that we're talking about of a string is actually an object of the string type, and we have various methods that allow us to create new strings from old ones. Again, a technical point here for Python is that strings are immutable in that they can't be changed in memory. So when we assign them to a variable and then change them, Python actually creates a new string to replace the old one. We'll have a look at that, and that comes back to the fore when we look at things like dictionaries, lists and tuples in a couple of weeks' time. And we'll talk about mutable and immutable strings and other data types. So with these methods, we can do something from simple, such as create a string that's all capital letters, or we can create a new string that's the result of some, intricate letter substitutions. So let's have a look at another program that's called quotation manipulation. Let's just change that and run it. Okay. So here we are. There's our output from it. And let's open up the code so we can have a look at it. Now, this program is using a quote from the chairman of IBM, Thomas Watson, in 1943, where he stated that the world market, maybe for about, I think there is a world market for maybe 5 computers. Boy, how he was wrong. So this is back in 1943. Ironic really that I'm actually using one of many computers that I own which I think is more than 5, to actually print that quote out. So let's have a look at some of the stuff here. So here we're going to print out the original quote, and I'm just putting the quote. So we've assigned it to a variable. This saves us having to type out those words again and again. We've assigned it to the quote variable, and I'm going to print the quote, which is there, original quote. Now, if I wanted to change all of the letters in that to uppercase, I can use a method which is attached to the string function. And in this case, it turns all of the characters into uppercase characters. So a string method, or a method of an object, if you like, is like an ability that the object has. So the quote object as a string has the ability to create a new string as a capitalized version of itself through this upper method. And we type that in just by putting in the quotes. Now our atom has identified we've got a variable called quote. And if I do that, it now brings me up a list of methods that I've got as part of the string. And we can see there that it's saying uppercase S is string, and this is the name of it, split, which allows us to split a string, which we'll look at a little bit later on. But these are all of the different string methods that we've got available. And there's our upper, which tells us, returns a copy of the string S, so in our case quote, will be converted to uppercase. And brackets on the end of that for the string function, and then brackets to close the print function. And there we go. So that's how we've called it, that's how we've used it. And then when we print it out, it prints a copy of quote, in uppercase. And likewise, I've used the same method here, and I've printed the quotes all in lowercase, because I've used the lower function. So again, that makes sense. I've used title case in this example, so all the first letter of each word is capitalized. And I've also used the replace string method, so whenever it comes across 5, it can replace it with this one. And you've used this function many times in Word because it's something akin to the find and replace option. But as you'll note, the original quote is still the original quote without actually being changed at all. That's because of the way that strings are immutable and only ever return a copy of themselves that's been manipulated. If we wanted to keep this copy, we would have to assign it to another variable. Now, strings aren't the only objects with methods. We'll find that lists and dictionaries and tuples as data types also have their own set of methods that we can use on there, as well as integers and floats also have some. Okay, and I've put together another Python file called useful string functions, useful string methods, which you can use as a reference, excuse me, as a mini help file to tell you what each of the methods do. Okay, so far we've used different types of data. So we've used strings to print data out to screen, we've used integers to capture whole numbers, and we've used floating point numbers to capture numbers that are fractional or have a fraction element which we recognize as having a decimal point. So it's important to know not only which data types are available to you, but also how to work with them and use the right one in the right context, so you don't end up with programs that produce some kind of unintended results. Okay, so let's have a look at our trust fund program, but a bad example of it. Let's change the permissions. Not run it just yet. I want us to look at the code first. Okay, so here we are using a triple string just to give us our input from that. So, this is a silly little program to capture guys, living off their £1 million trust funds and their rich bank account in the Seychelles. But this program, is meant to help those living beyond any reasonable means to stay within their budget, so they don't have to think about getting a real job. It's a silly example, but it does have a purpose in this context. So, let's have a look at the program. Alright, fairly simple. We're going to take, so please enter the requested monthly costs, and just deal with whole pounds. Right. So let's run it. Okay, so let's enter some figure for our Aston Martin tune-up. So let's say £2,000. Our central Manchester apartments, £1,000. Our private jet, 17,000. Just to get from one end of bolt to the other. Ooh, I'm going to spend 5,000 on gifts and 75,000 on dining out because I don't ever want to cook. 12,000 on staff because I'm tight. I've got a personal guru. And I spend about 5,000 a month on games. Now, before I hit the carriage return here, we can do some simple maths and we can work out how much that's going to cost. And we'd expect that to be returned back out to us. But let's have a look and see what is returned. Okay, so our grand total there is an unimaginably large number that I've got no intentions of trying to pronounce. But something's not quite right here, because even with our best estimates, we can see that the figures that we've entered into the program don't come anywhere close to an integer that large. So clearly, we've got a program with some unintended results or a logic error, but because it's just a logic error, this program doesn't crash. Yeah? So it's working, it's all valid code, but it doesn't produce the intended results that we had. Now you can probably figure out what's happening by simply looking at the code. Yeah? And if we have a look down here at the long number, if we split that number up, we can see that it represents quite simply the figures that we've entered in here. And the output tells us a story as well in terms of the number being massively large. Okay, so this is the line that undertakes the addition, but it's not actually undertaking any addition. Let's remember back to when we were talking about operators and operator overloading. In the context of strings, this joins them together. Okay, so it tells us quite clearly that the program did work as programmed. We have taken the input in the form of a string, we have assigned it, to the car variable, or the car variable gets the string from the input as a return value, and we've concatenated those together to produce our intended output there. Okay, so that's the problem. Now don't forget, this concatenation aspect is called operator overloading, and it allows us to manipulate certain operators so that they have a contextual element to them. Now what we want to do is we want to be able to fix our program so that we can take our string values and have those returned back to us in something meaningful that we can manipulate. Now our program says that we just need to enter whole pounds, right? So in this context we can rest assured that we're going to use integers. Now I've already done this once before in an example where we're going to convert one data type to another. Now there are two ways that we can do this. So we can take our string, coming from the user, in this case we entered 2000, and we can assign that to the car, and then we can add a line in there, right, which will be car equals int, call the int function, assign the car string, excuse me, space, there we go, and then we can return that back. So this line is the line that does the conversion. So the function int takes the string referenced by car and returns an integer version of it, which then stores it back into the box called car, right? So this is in essence is replacing a string value with an integer value. Okay, so remember on the box has the label of what we're calling it, but it also tells us what type it is. So there, car contains a type string, and here it contains a type integer. That's also in some programming languages called casting. Yeah, but converting is fine. Another way that we can do it, to make it a little bit quicker, is we can put the int function, or float if we wanted, there, and that does exactly the same thing as that line without having to write the extra code. So this is done in just one line. This is because we've got the two function calls, int and input, nested. So nesting function calls simply means putting one function inside another function. This is perfectly fine as long as the return values of the inner function are acceptable to the outer function. So here the return of input is a string, and a string is perfectly acceptable to be converted into an integer. Okay, we've got the caveats there that the actual string has to be a numeric value, but that's fine. Okay, so we can carry on doing that all the way down our program until we've got it completed. Now, let's run our good version of the program. Double line. Okay, and we'll go through the same data set as we put in before. Okay, so £2,000 for our Aston Martin tuner, £1,000 for apartments, £17,000 for my jet, okay, and now we're getting a grand total out of 56,300. That's because these variables are now integers. And I can prove that by just amending the program. I'll put print, and I'm going to call another function in here now, type, and I'm going to pass it. It's asking for an object. I'm going to give it car as our variable object there. Okay, so let's just put some information there so we can see where we are. After user input. Okay, then we'll call our user input. Change that to after conversion by int function. Save that. Run it again. Okay. So here we are now. I've got the input here. Aston Martin coming up. Tune ups. Let's put in 2000. Run that. So here we can see. After user input, the class, the type is a string. This line is then run, and it doesn't return any output, so we're not going to actually see anything. But we can prove it by checking what type the car is now, and we can show that there that it's changed after conversion by the int function to an integer. Okay, so this allows us to manipulate strings and various other different values and to change those into other data types that we might want to manipulate. Okay, so let's move on. Okay, right, I want to touch on something called augmented assignment operators. Okay, let's just control clear that a lot down. And let's run a program which we've got in here. Augmented assignment operators. Okay. Now, you might have seen that we've already called an integer here and reassigned it back to ourselves. Yeah. But we can do it in easier ways within Python. Right? And these are what we call the augmented assignment operators. But the concept is simple. So let's say you want to know the yearly amount of food, yeah, the user spends on food. So we could use the line food as an integer, yeah, equals food times 52. Let's create the variable because it's not been used before. So food equals £100 a week. Okay. So that's quite simple. That makes sense. So we're taking the value stored in food here. We're going to multiply it by 52 and then put it back in the box. Now, an augmented assignment operator allows us to write this in a much simpler way. So food multiply equals 52. Okay, does exactly the same thing. So it also multiplies the value of food by 52 and then assigns the result back into our food variable, but it's much shorter than the first version. Yeah? So these are nice shortcuts to a lot of common tasks that you often undertake inside programming. And this program here, the augmented assignment operators.py, gives you again another little help guide to see how that they're used. And obviously you've got those there that you can refer back to. So I think that's pretty much covered everything that we wanted to cover. So now let's go back to our useless trivia program. Okay. And take a run through that. Okay, so initial comments. These, I've used the triple string form of initial comments because I wanted to put those over multiple lines. I could of course use the hash octothorpe or hashtag to be able to do that. What I would say is a big hint that we always use initial comments to describe any elements that you make to code over time. So always when you first write your file, your Python file, put your initial comments over. Right? So for example here I've given the file name, I've used how to get personal information from a user, And I've also used a Python magic variable, don't worry about that, we'll come on to those later, to store the version of that. Yeah, it's really useful to get your hands on this. So let's put into practice now some of the things that we've looked at. So to get input from the user, we're going to use our input function, and we're going to request our 3 pieces of data: name, age. Yeah. We're going to convert our age to an integer by calling the int function, and then we're going to get the weight, but this time we've used the float function and done it all in line to supply it back to weight. So we've got our input to a variable, we've then converted that string to an integer and assigned it back, and for weight we've done the same thing but on one line with a long nested function call and assigned that back, just to demonstrate that you can do those. So we're going to now print some uppercase and lower cases of the name. Right, now assuming that you put the name in lower cases when you typed it in, but you might not have done. So let's add the lower function into that. Let's save it. Okay. I can of course break this onto a new line, providing that my indents match, as you can see. That's mostly acceptable. Oh, missed the comma, that's why. Okay, so again I've put it over a new line to make it readable, and I've indented according to where it requires. Okay. So that's the lower, and now if Richard Dawkins was shouting at us because he's mad, he would then use upper characters. Okay, so as we carry on doing down here, so if a small child is trying to get the attention, we're going to, what is in essence, multiply the string. Okay, and I've used escape sequences here to put a new line character in, but yeah, I've also used a single backslash, which allows us to continue Python commands over multiple lines. Note that this one isn't indented. Yeah? That's because as far as Python concerns, when it sees that single backslash there, it says the string's just continuing and to ignore the carriage returns. So there I've printed the name out 5 times. I've done some mathematics in our program, and I've calculated your age in seconds. So that's done by these 2 lines here. So since there are 365 days in a year, 24 hours in a day, 60 minutes in an hour, and 60 seconds, and I've multiplied that as a product of age, that will gives us the seconds, which is assigned to the string variable, and it's then printed out inside our string. So the next ones are calculating our moon weight and sun weight. So we've done something simple, similar here. We've taken our integer for weight and we've assigned it and divided it by 6 to get our moon weight, and then we've printed that out, and we've done the same thing there to get our weight on the sun. Although it's interesting to note that our mass wouldn't actually change, only our weight would. That's due to the gravitation. Mass doesn't actually change. There we go. And the last statement waits for the user to put input in by simply pressing the enter key. And as we've seen, we've used that a number of times to allow the Python program to wait for us to finish. It's much more useful for people running the Python files on Windows than it is here. So let's run our program again, just to refresh us how it went. Oh, sorry, don't need that. Trivia. Brent. Okay, and there we go. That's printed out the rest inside our trivia program as expected. Okay, good stuff. So, to quickly recap, we've created a number of strings with single, double and triple quotes. We've used special characters and the escape sequences that allow these special characters to be printed and displayed and used in formatting our strings. We've joined strings using concatenation. We've repeated strings using string multiplication. We've got different numeric types that we've used, integers and floating points. Okay, we'll come on and look at other ones such as complex numbers and scientific numbers at a later date. We've looked at how we can use those and the mathematical operators that we can use to perform simple mathematics on those. We now know how to convert values between strings and floats and strings and integers. You can also convert integers to floats and floats to integers using the same way. But bear in mind, if you convert a float to integer, you will lose any decimal points. And we've also recapped on variables and show how we use them to store and retrieve information. And finally, we've also learned how to use user input to make our programs interactive. So I hope you found that really useful. I will upload the variable strings and IO folder up to Moodle along with this video. And of course, if you've got any questions, then please feel free to email me or stick them up on the forum. Thank you.